Free fall. Free fall is a special case of acceleration, and I promise this video is a whole lot shorter than the last one. 18 minutes, golly gee. Okay, so gravity causes acceleration. Free fall is only under the influence of gravity. So if you're holding a pen, it's not in free fall. If you have a rocket attached to a pen, it's not in free fall. But as long as nothing is acting on it except gravity, we have free fall. All objects near Earth, I'm guessing you remember this number, accelerate at the same rate. G is 9.8 meters per second squared. So G, special acceleration, gravitational acceleration. We'll use the symbol sometimes, other times we don't. Now this is if and only if, remember this symbol, negligible air resistance. And I'm going to go ahead and use that word. It shows up on tests. I don't tend to use it in my problems, but if I've copied them from someplace, it shows up on the AP exam, it'll show up on my tests. It showed up on some of my last year tests. Negligible means minimal. So if we can ignore air resistance, all objects near Earth accelerate at the same rate, so mass does not matter. We will actually deal with air resistance in this class, but not for a long time. I'm saving that till April so that your calculus skills are ready for that. So directions do matter. Because gravity always causes acceleration downward. Again, you know this. Of course gravity pulls things back down. By the way, down means towards the center of the Earth. It's the direction things fall if dropped. So people on the other side of the world would not say that their ball is falling up. It's, for them, it's falling towards the center of the Earth, so that's their local down. So directions matter. Sorry, just fun thing. If you drop something, it's only going to move down. If you throw it down, it's only going to be down. So since these are only downward motion, make down the positive direction. Because gravity will be a down, it will move down some displacement, it will have velocity downward, everything will be down, so make down positive. For the special case of dropped, I want to remind you, equation 2, I'm going to drop the delta for this derivation, x equals v naught t plus 1/2 at squared. If it's dropped, then v naught is 0. It's not moving at first. If it's not moving, this term goes away. So x equals 1/2 at squared, and we can really quickly solve this for t. Multiply by 2, divide by acceleration, and then take the square root of the whole thing. So it's a quick derivation, but it's also really helpful to have that memorized. That always applies to dropped things, and it makes your life so much easier just to do that faster. Now, we will have situations where an object is thrown upward. In that case, we have both up and down in the same problem. The initial velocity is going to be upward. Gravity is always down. So we have two opposite directions. You still choose to make up positive or down positive. Totally up to you. But whatever you make positive, the other direction has to be negative. I get confused if I try to reverse those. So in this case only, I choose, so Mrs. Stat's choice is to do up as positive. Then it's just like the y-axis in math class. So I would have an initial velocity of a positive, let's make up a number, 10 meters per second. And of course our acceleration due to gravity, negative 9.8 meters per second squared. And then you would need to be careful about displacement. So if an object is thrown from the top of this hill and ends up the bottom, this displacement is negative 40 meters because this ball ended up 40 meters below where it started, and we made up positive for this one. If, on the other hand, it's thrown upward, and I want to know, and pretend that's in a straight line, I want to know the max height. Well, or if I'm given the max height, this number would be a positive 5 meters, because max height is above where we started. So especially if you're given a displacement in an upward thrown problem, be really careful about the sign on that too. Some of you will be remembering that we often used 9.8, we rounded to 10. That's fine. In this class also, the multiple choice will actually assume you're using 10 for gravity. And then on the free response, I will work 2 keys if necessary for a gravity problem, so that 9.8 and 10 will both get full credit. It's really helpful if you make sure that you write that down someplace, but it's okay, I'll know what you're doing. Let me check my notes. I did. So remember, gravity's always down, and how you symbolize that mathematically matters.